Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about work, torque, and power in metric units. In my previous video we talked about work, torque, and power in imperial units, and this time we're going to take a look at the same formulas, but we're going to talk about what the units should be if you're working with metric. So our definitions stay the same. Work is still defined as force times distance, but now you're going to be measuring force in newtons. Distance should be in meters, and then work will be in Newton meters. You may also see joules used as the unit. A Newton meter is equivalent to a joule. I'll leave it as Newton meters just because I think it's easier to understand. Let's take a look at an example. It asks us to find the work expended to raise a force of 500 newtons, a distance of 3 meters. So our work will be equal to the force of 500 newtons times a distance of 3 meters, which is 1500 Newton meters. Now let's take a look at torque. Torque is the same as work, except that it's work in a twisting or circular motion. So when we're talking about distance with torque, we're referring to the radius of the circle formed by that twisting motion. So our force is still measured in newtons. The radius is still measured in meters. So the torque unit is Newton meters. If we were asked to find the torque developed by a force of 75 newtons acting through a distance or radius of 0.4 meters, we would simply multiply those values. So 75 newtons times a distance of 0.4 meters, that's going to equal 30 Newton meters. In our next example, we're told that the torque on a shaft of radius 0.1 meters is 90 Newton meters, and we're asked to find the force applied to the shaft. So in this example, we know torque, 90 Newton meters, and that's equal to force, which we don't know. I'm going to just call it F, times the radius, which is 0.1 meters. If you want, you can drop the units and just write that as 90 equals 0.1 times F. And in order to solve for F, we need to isolate F, which means because it's being multiplied to 0.1, to eliminate it or isolate it, we need to divide by 0.1. Whatever we do to one side of an equation, we have to do the same thing to the other side. So it will cancel on the right side and we'll just simply be left with F. On the right side, 90 divided by 0.1 is 900, and that's force in newtons. Now let's talk about power. In the previous video, we talked about the definition of power, defined as work divided by time, or in other words, the rate of work. And work is defined as force times distance. So power is force times distance divided by time. The units are very important. We know force is measured in newtons, distance is measured in meters, and time needs to be measured in seconds in the metric system. That's our base unit for time. And with those units, power will be measured in watts. So 1 watt will equal 1 Newton meter per second of power. Let's take a look at a couple of examples. In our first example, we're asked to find the power needed to apply a force of 1,000 newtons through a distance of 6 meters in 5 seconds. So our power in watts will be equal to the force of 1,000 newtons times the distance of 6 meters divided by a time of 5 seconds. When we multiply 1,000 times 6 and divide by 5, we get 1,200 watts, and we can express that as 1.2 kilowatts. Okay? 1 kilowatt is equal to 1,000 watts. So we can just simply move our decimal point 3 places, in other words, divide by 1,000 to change watts to kilowatts. In our last example, we're told the power of a motor, 3 kilowatts, and we're told that it takes that motor 1 minute to raise a 20,000 Newton object a certain height. We're asked to find the height. So in this case, we know all of the values except distance. But we have to be very, very careful with our units. 3 kilowatts, we need to change to watts. So remember, 1,000 watts is equal to 1 kilowatt. So 3 kilowatts will be 3,000 watts. So we're going to put 3,000 in. I'm not going to bother with units in this example. Just make sure that you pay attention to the units as you're putting your numbers in. The force is in newtons, 20,000. Distance is what we don't know, so I'll call that capital D. Divided by time, which needs to be in seconds. So we're going to write our time in seconds, and then that's what we put into our formula. We want to solve for D. One way that we can do it is take 20,000, divide by 60, and get one number times D, and then divide both sides by that number. But because that number contains decimals, I'm going to do this a little bit differently. I'm going to start by getting rid of the 60. D is being divided by 60, so I'm going to multiply both sides by 60. The 60 will cancel here. 3,000 times 60 is 180,000. Now I'm going to get rid of 20,000 by dividing. If I divide the right side by it, I need to divide the left side by 20,000 as well. We'll cancel here, and I'll simply be left with D. 180,000 divided by 20,000 is 9. Distance is in meters. So that motor lifted that object 9 meters. The formulas for work, torque, and power are the same whether you're working with imperial units or metric units. However, with power, it's a little bit different because our time is in a different unit. And in the imperial system, we had to deal with the 33,000 when we're dealing with horsepower. The key is making sure that your values are expressed in the correct unit before you proceed.